Hi, Mr. Simone from Hamden Middle School again here. For today's video, we're going to look at linear equations. We're going to look at three different types that we've talked about. We've got slope-intercept, which the equation actually highlights the slope and the y-intercept. That's where the name comes from. Point slope, which is derived from the slope formula, where we're going to look at a particular point and the given slope to help us find other points on a line. And then standard form, where we're given ax plus by equals c, and we're going to look at how we can identify or review how to find the x-intercept and y-intercept. So they all have different, different capabilities or different ways of representing these pieces of information. But from all of them, we'll look at how we can use what's given. So that's what today's going to be about. We're going to start with the slope-intercept form first. All right. At any time, if you need to freeze this video, you can. All right, so the first one, our y equals mx plus b. And for this one, we're just going to go through what pieces of information are given and how we can use that information to graph. And we'll do those for each of the equations. So this one we'll do y equals 1/2 x plus 2. All right. From the equation, we know that this represents our slope, which is the change in y over change in x, which is m. And this part of our equation, the b, represents the y-intercept. You could say b equals 2, or more importantly, you have to know that it is in fact the y-intercept. And I'll put this over here for slope. All right. So the way that we can use this information to help us graph is you start out with your y-intercept. It's kind of a good place, just a good starting point. So we look at our y-axis, we're going to plot 0, 2. That's where we start. Then we can use the slope, which basically tells us our rate of change, how we change in the y compared to the x. And if you notice here, the 1 is positive, so it's going to tell us we're going to be able to go up. And the x is also positive, which is the x direction, which is to the right. So what we can do is we plot our 0, 2, and then we use the slope to plot other points. So up 1 over 2, another point, up 1 over 2, and continue that pattern. If you wanted to, you could also go in the reverse. So instead of going up 1 and to the right 2, you can go down 1 and to the left 2. And that's basically like saying -1, or the direction -1 by -2. And again, -1 divided by -2 is 1/2. And you can continue the pattern all the way through. Now I usually tell my students to have at least maybe 1 or 2 points, but the most important one here is that y-intercept. And then you just graph it, including the arrows on the end. So that's slope-intercept. Use your y-intercept, then use the slope to plot the other points. All right. The next one we'll look at is point slope. All right, so point slope is the form y minus y1 equal to m times x minus x1. And as I said before, this one is derived from the actual slope formula, which is that whole y2 minus y1 over x2 minus x1, where m is your slope. And you can kind of rearrange the equation to get that. But ultimately, if you're given an equation in this form, what they're doing is they're giving you a particular point along with the slope to hopefully help you find other points on the line. So for this one, we'll do this. We'll do y minus 1 equals 1/2 times x, and we'll do plus 2. Okay? So if you were given this form, it tells us that our slope, our change in y over a change in x, is 1/2, which again is that m. It's also telling us a particular point. Now whenever we talk about particular point in class, I'm talking about what value for x and what value for y will kind of zero out both sides of our equation. Well, the only value that works for x to try to get this to zero out would be -2. And over here, for the y, the only value y could be to have both sides balancing itself, 0, would be +1. 1 minus 1 is 0, And then negative 2 plus 2 is also 0, and that would allow us to know that that particular point is on the line. And that's where the name comes from, is that it's point slope. So here's our particular point, which balances out our equation, and here's our slope. So you plot your particular point, which is going to be negative 2, 1, which is this point right here. We use that particular point along with the slope to now graph our line. So just like in the last example, the slope is 1/2. So I know I can go up 1 over 2, up 1 over 2, up 1 over 2. And just like in the last example, we can also go down 1 and to the left 2 to create our line. So the only real difference here between our slope-intercept, which was the first one, and point slope is that slope-intercept would tell us exactly what the y-intercept is, and you can use the slope to graph it. This one just giving us a particular point, a point somewhere on the line, and we can use a slope to create the actual line. So that's what point slope is used for. So the last one, standard form. So for standard form, it is the form ax plus by equals c, where a, b, and c are integer, whole number integers, and a has to be a positive integer, whole number integer. All right, so for this one, we're going to use x minus 2y equals negative 4. All right, just going to put that out there. Whenever you're given a value or you're given an equation in standard form, the key thing about standard form is that it allows you to find your x-intercept and y-intercept, and that'll help you graph. It'll also help you find the slope. So for this one, what I normally tell my kids to do is if you're given something in standard form, is to identify your x-intercept and y-intercept, and all we need to do is plug in 0 for x to find our y-intercept, and then you can do vice versa where you plug in 0 for y to find our x-intercept. So this is one of those things that I tell my kids that it's an easy way to find your values. So for this, if I want to find my y-intercept, plug in 0 for x, cancels out x, so x is not there anymore, and you're left with negative 2y equals negative 4. The only thing that y can be to balance it out is positive 2. So that's going to be this point, 0, 2. At the same time, we wanted to, we plug in 0 for y, cancels out, it cancels out the negative 2y, so you're left with x equals negative 4, which is this coordinate point here. Once you have established your two coordinate points, your x-intercept and your y-intercept, you can connect them, put arrows on the end, and you have your line. If you wanted to, you could try to find the slope. You can either rearrange your equation or what we talked about before, to find slope, it is change in y over change in x. And this is a positive slope. We're going to go up 1, 2 spaces and over 1, 2, 3, 4. So my slope is 2 over 4, which is equal to 1/2. So this is just kind of a quick review of like how we use the different equations and how you can use them to graph, how you can use them to help. There's going to be some other videos where I'll actually show you how we can kind of derive the equations, these three equations we talked about, from one another, which is kind of an interesting, fun little thing. So I hope this helped for now, just to kind of briefly discuss the pros for each of the equations and how you can use them to help you graph. So best of luck.